Hello everyone, welcome to your channel Data Science Studio, and today we are going to start with day 6 of statistics for data science. And today we are going to start with a very important concept in statistics, which is probability. So let's get started. So today we'll be discussing about some of the key concepts like what is probability, what is event, what is sample space, what is combination, and what is permutation, and with couple of examples. First of all, we have to understand what is probability. So probability is a numeric measure. So probability is a numeric measure of how likely an event is to occur, and its value is always between 0 and 1. Now what we have seen so far we have discussed several methods of summarizing sample data to gain knowledge about the entire population. So till now we were studying like how you can summarize the data and get the details about the population. But if you want to make inferences about the population, so which we call it as inferential statistics. So if you want to make inferences about the population, you have to understand and you should have a good knowledge about statistics, the probability distribution, and various related statistical techniques for the inferential statistics. And in that, first of all, we have to understand probability. So it is a numeric measure of how likely an event is to occur, and the probability value always lies between 0 and 1. So the basic concept in probability is a random experiment. So a random experiment, we call it also as a trial or process. So a random experiment is an activity that produces an observable outcome that could not be predicted in advance. For example, if you are tossing a coin. So tossing a coin is a random experiment because you will not know in advance whether you will get head or whether you will get tail. So that becomes a random experiment. Next thing is, what is a event? So events are nothing but these are the outcomes of your experiment, and they are denoted by capital letter E. So each experiment may result in one or more outcomes. So for example, if you are rolling a dice, and a dice can have six outcomes. So it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. So there are 6 outcomes. So event is nothing but there are 6 outcomes are possible in this particular event, and it is denoted by capital letter E. Next is, what is sample space? Now sample space is the set of all possible outcomes of an experiment, and it is denoted by capital letter S. So if you are tossing a coin, so a coin can have only 2 faces, which is head or tail. So your sample space is 2. So your sample space is 2. And let's say you are tossing 2 coins. So your event 1 could be you have both heads, event 2 could be you have head and tail, and your event 3 could be you have tail and head, and event 4 could be you have tail and tail. So these are the your sample space, and these individual are the events. So what is event? Every experiment result in one or more outcomes. So first outcome is you can get two heads, then you can get head and tail, then you can get tail and head, and you can get tail and tail. So these are the sample space. So sample space, set of all possible outcomes of an experiment. It is noted by capital letter S. Now there is another concept. Now there are some properties of the sample space. So there is another concept which is called as mutually exclusive events. So what are mutually exclusive events? So when two or more events cannot occur simultaneously in a single trial of an experiment. So for example, if you are flipping a coin, so your either head will come or tail will come. So when two or more events cannot occur simultaneously in a single trial of an experiment, then such events are called mutually exclusive events, or we also call it as disjoint events. And events which cannot occur together or simultaneously. So if you are flipping a coin, either you will get head or you will get tail. So both are mutually exclusive events. Now next important concept is what is a independent event and what is a dependent event. So when two events are said to be independent, when the outcome of one event does not affect the outcome of another event. So if you are rolling a dice, and if you are rolling it for the first time, you are getting 5. If you are rolling the second time, you are getting 4. So these two are independent events, because the probability of getting a 4 and probability of getting a 5 is not dependent upon each other. They are independent event and they are mutually exclusive as well. And the events are said to be dependent when the outcome of the first event influences the outcome of the second event. So for example, if I have a pack of 5 cards and I pull a card at random, so I get 2. So the probability of getting 2 is 1 by 5. Now this card I am not putting it back, so my sample space reduces to 4 now. So what is the probability of getting a 3 then? And the probability of getting a 3 is 1 by 4. So my probability changes because I am not doing with replacement, I am doing it without replacement. So my probability of getting a 4 in the second draw changes, and that's why it is called as dependent events. When the outcome of the first event influences the outcome of the second event, it is called as dependent events. And next is we have what is compound event. So when two or more events that happen at the same time. So it is like you are flipping a 2 coins at the same time. So if you are flipping two coins at same time, it is a compound event. And what is equal likely event? So these are the events that have the same probability of occurring. So if you are flipping a coin, the probability of head is 1 by 2 and the probability of tail is also 1 by 2, and both are equally likely events. Or if you are rolling a dice, any number which you are getting on the dice is a probability of 1 by 6. So these are called as equally likely events. And there is another concept which is called as complement. So complement is denoted by E bar is equal to S minus E. So everything which is not part of the event will go into complement. So for example, if the probability of getting a head is 1 by 2, then the probability of not getting a head is 1 minus 1 by 2, which is again 1 by 2. So this is the probability of not getting a head. So complement is actually all outcomes not part of event. So all outcomes which are not part of event is a complement. And when we are talking about approaches of probability, there are two approaches of probability. One is called as classical approach, another is called as relative frequency approach. So what is classical approach? So it is based on the assumption that classical approach is based on the assumption that all possible outcomes of an experiment are mutually exclusive and equally likely. So my probability of A is number of favorable outcomes divided by total number of possible outcomes. So for example, if a dice is rolled, what is the probability of getting a 1? So number of favorable outcome is only 1 because there is only 1 in the dice, and total number of possible outcome is 6. So this is the probability of, this is a classical approach of probability, which is all the events should be, outcomes should be mutually exclusive and equally likely. There is another concept which is called as relative frequency approach. So when the outcomes of a random experiment are not equally likely, then it is called as a relative frequency approach. So let me give you an example. So for example, let's say you are conducting a random experiment and we may or may not get a desired event. For example, if you are rolling a dice, you are getting 1 by 6, you are getting 2 by 6, but you are not getting 5 by 6 frequently or over a period of time. So what happens once you start repeating this experiment multiple times? So let's say you are rolling a dice 500 times. So you will certainly get some proportion of your rolling dice which you will get 5 by 6. So certain proportion of time you will get 5 by 6. So thus the relative approach calculates the proportion of time. With which the event occurs. So the probability of event A in this case is equal to limit n tends to infinity your sample space divided by n. Now what is this C of S represents? This C of S represents number of times 5 by 6 occurred. So let's say that you are rolling a dice 500 times and 10 times you have got the 5 in the dice. So your probability will become 10 by 500. So this is the relative frequency approach, and where the probability is actually the proportion of time in which a particular event occurred. Now there are certain rules of probability. So probability value always falls between 0 and 1. We are very clear about it. And sum of the probability of all simple events is equal to 1. So for example, let's say you are tossing a coin. So probability of head is 1 by 2 and probability of tail is 1 by 2. So total probability will be equal to 1. So total probability of all simple events in a sample space is always equal to 1. And in case of probability rule for complementary events, we have discussed P of A bar is equal to 1 minus P of A, probability of A. This is probability of A bar is called as complementary event. Now we'll talk about what is combinations. So it is a kind of a counting technique wherein the order is not important. So it is a mathematical technique where ordering or arrangement of objects is not important, and when order is not important, it allows us to select R number of outcomes from a collection of n distinct outcomes. So the formula for combination is Cn by R is equal to NCR is equal to n factorial divided by R factorial into n minus R factorial. So this is the formula to calculate the probability of certain event. So we'll see some examples, and there is another case which is called as permutation. So in case of permutation, order matters. So in case of combination, order does not matter. So 1, 6 and 6, 1 both are same events. But in case of permutation, 1, 6 and 6, 1 both are different events. So the formula for permutation is P n by R is equal to NPR, n factorial divided by n minus R factorial. This is the formula for permutation. Now let's solve certain questions. So for example, let's say that a student purchased 10 pen drives, out of which 3 are defective, but it is now known which are defective. In how many ways 3 pen drives can be selected? So there are 10 pen drives, out of which 3 are defective. So you have to select 3 defective pen drives out of 10. So 3 defective pen drives out of 10 can be selected in 10C3 ways, which is 10 factorial divided by, this is your R and this is your N, NCR, and the formula for NCR is n factorial divided by R factorial into n minus R factorial. So which is 3 factorial into 10 minus 7 factorial, which is 10 factorial divided by 3 factorial into 10 minus 3, it is 10 to 7 factorial, which is equal to 120. So there are 120 ways in which 3 pen drives can be selected. And how many of these selections will include at least one defective pen drive? So there are 120 ways which may include defective or non-defective, but how many of these selections will include at least one defective pen drive? So there are number of ways. So it can be one defective pen drive, 2 defective pen drive, and it can be 3 defective pen drive. So when we are talking about 1 defective pen drive, then there are 7 pen drives which are in good quality, and you will multiply it and you will 3C1. So 3 are defective pen drives, right? So out of 3 you will select 1 defective, so rest will be from good pen drives, so total will be 63. Another option is you select 2 defective pen drives. So if you select 2 defective pen drives, then it will become 7C1 into 3C2. Why this becomes 1? Because you have to select total of 3 pen drives only. So this will become 85. 21. And in the third case, when all are 3 defective, then it will become 7C0 into 3C3 is equal to 1. So total number of ways in which at least 1 defective pen drive should be selected is 63 plus 21 plus 1 is equal to 85. So there are 85 ways in which at least 1 defective pen drive can be selected. Now we'll see another example. So a bag contains 5 red and 7 green balls. So if one ball is drawn at random, then what is the probability of the ball being green? So first of all, we have to calculate our sample space. So we have total of 12 balls and we have to take one ball out of it. So there are how many ways? 12 factorial divided by 1 factorial into 12 minus 1 factorial, which is equal to 12. So there are 12 ways in which one ball can be drawn at random. So and we have to find what is the probability of ball being green. So how many green balls are there? So we have 7C1 is equal to 7. So the total probability is 7 divided by 12. So this is the total probability of getting the ball being green. Similarly, if 2 balls are drawn at random, then what is the probability that one is red and the other is green? So you have to select your numerator. So the ball being red is 5C1 and the ball being green is 7C1, which is equal to 35. And since you have to select 2 balls, so your denominator will become 12C2. So there are 12C2 ways in which 2 balls can be selected, which is equal to 12 factorial divided by 2 factorial into 12 minus 2 factorial, which is equal to 66. So total number of ways in which 2 balls can be selected and out of which one is red, one is green is 35 by 66, which is 0.53. So 0.53 is the probability of getting 2 balls out of which one is red and one is green. We'll see one last example. So in a single throw of 2 dice, find the probability of getting a total of 6. So we have to get a total of 6. So what is my sample space? Sample space is 6 into 6 because there are 2 dice, 36. So in how many ways you can get 6? So you can get ways in 3, 3, 2, 4, 4, 2 and 1, 5 and 5, 1. So in these many ways you can get the 6. So total number of outcomes will be 5 divided by 36 is 0.138. So there is a 13.8% chances you will get a total of 6 when you are rolling a 2 dice. And what is the probability of getting a total of 6 or 11? So that is also very easy. So 11 you can get in two ways. One is 5 comma 6 or 6 comma 5. So your total number of possibility, if you add, you will have 7 outcomes out of 36, which is 0.19. So there is a 19% probability that you will get a total of 6 or 11, and there is a 13.8% probability that you will get a total of 6. So this is some from the perspective of some of the basic functionality of probability, and next session we will talk about what is marginal probability, what is joint probability, and what is conditional probability. So please subscribe, like and comment your channel and provide your feedback on the content as well, and stay tuned and stay connected. Thank you.